As we discussed in the last class, actually, we directly focus on the RCC design. This is module 2. Okay, hope you all know that myself Sayed. To introduce myself, I mean, in a very simple way, I'm an IIT graduate, BTech, and as well as IIT graduate from MTech as well. So my specialist in structures, been handling both the RCC and steel, and in addition to aluminium, wood, and everything. He knows plastic. Uh-huh. Okay. So now going with directly the module of RCC manual calculation, because our focus is which is related to completely manual calculation. Okay. Though it has been written as module 1, I mean, because we have seen couple of the basic things, I mean, couple of basic things in module 1 in the last class. This is in continuation to the module 1. This is in continuation to the module 1. Okay. Which we are going for what do you call which will go with the beam designer. Yeah. Can you see the live project here, which we've been focused on the villa design? Okay, you could be able to see the structural comes architectural drawing of villa. Yeah, it's a superimposed drawing. It's all the black colors. It's all showing the columns, vertical columns, and of course, the column to column which is connected, it's all beams, isn't it? Because in villa, most probably they don't go for flat slab design. Okay, the first the difference is what I mean. There are two kind of frame system. One is, I mean, as a typically, normally we used to go for what I mean, frame system, which the beam is being connected in both the direction of the columns, X direction and Y direction. Okay. The second system is called completely as a flat slab, which we don't have any beams. The column is directly connected to the slab. Okay. Another way of to check in terms of flat slab, which is critical, is punching shear. Okay. At any case, both the calculation we need to do the shear check. But in terms of the frame structure, the one which is connected to the columns to the beam itself which will take the shear. The second one, if we focus on flat slab, which will directly connect to the slab, since you don't have the sufficient stiffness, because the slab thickness probably in general you can go for 20 centi and not more than 23 centi, because if you talk about even in a buildings, I mean, it's very rare to go more than 25 centimeters of slab thickness. So most probably the slab thickness within the range of what 20 to 25 centimeters. You get my point? Okay. This 25 centimeters with the span of assume if it is 8 by 8, 9 by 9, 10 by 10 actually, those sometimes it will not be sufficient to satisfy the shear. Okay. So the main critical is in terms of design is shear. Okay. Of course, there is moment which is bending moment is there, and bending moment which is indirectly proportional to reinforcement check. I don't want to confuse you. Let's focus on the live project here. I mean, okay, we can do it bigger span here. This span is what actually 6.5 meters. Okay, and this one is what actually 624. The reason why it has been given separate dimension, because we do have multiple columns here. So we wanted to directly give you how do you calculate the beam and as well as column and foundation. In general, the load which is transferred typically from slab to beam, beam to column, then column to foundation. Is that clear, right? Actually, this is where the loading part. Okay, any kind of buildings, I mean, if you talk about the loading part is what actually the load is directly goes to the slab, because slabs is connected to the beams. The beams is connected to the columns, then the columns is connected to what? Which is transferred to foundation, right below the base. Okay. Now the question is, what if we don't have beams? Say, which I said, the second option for the frame structure, you're directly going with the flat slab option. So in that case, I mean, the load which is goes to the slab directly to the columns, directly to the foundation. Okay, there was only one element which we will remove, the beams actually, which you will have it or we don't have it. It's up to the designer perspective whether you can have it or you don't have it. Okay. Now let's focus on what you call beam design here. Okay. So Okay. Fantastic. So as I said, like, what do you call the load which is transferred to slab to beam, right? In such case, what actually you need to calculate the slab thickness because the load is induced from the slab to beam as well. Okay. So in addition to the load, what you are talking about, say for an example, what are the loads we are talking about here in the last class? Actually, remember, I mean, when you talk about the loads, there are two kinds of loads. One is what? Gravity, another one is lateral load. Don't tell me like, when you talk about the loads, actually you're talking about dead load, SDL, live load. There are only two kind of load. One is what? Gravity load. Another set is like lateral load. So under gravity is what actually? Dead load, SDL, live load. What is SDL? Which is superimposed dead load. Okay. Dead load is what? Self weight of the particular structural element. Okay. So I'll go here. So when you talk about this column, I mean this column, okay, the influence line diagram. Remember last class we have seen the influence line diagram. Influence line diagram is what? Half of the distance from the adjacent supporting column, half of the distance from the adjacent supporting columns. What is the distance here? It is 6.5 meters. What is the distance here? Actually, 7 meters. So half here is almost how much? 6.75 meters. Okay, and fantastic. I mean, here it is what actually 264, but there is an adjacent column here, so which is 6, which is 3 meters half, and this is adjacent column here 4. So half is what? 2 meters. So 3 plus 2, which is 5 meters. You get my point. So 5 multiplied by 6.5. This is the influence area regardless of the loading. You're not talking about the loading here. Huh? You're only talking about what? The influence area which X1 which is going to govern the load to the columns. You get my point? Okay. That's called 5 to 6.3, 33.755 meters. If you talk about this column, so what is the distance here? 2 meters. So which is 1 meter. Okay. And this distance is what? 7 meters. Correct actually. But it will not be 7 meters because I have a column. You get my point? Then it could be 3.5. So 3.5 half is what? 1.65. Okay. 1.651. So that is 1.65 square meters. So typically is what actually when you don't have like adjacent continuous panel, then you can take it only like the corner portion, whatever the loads which is going to be governed to the particular elements. Okay. So I'll move forward actually. So minimum depth. Now coming to the point is what actually beam depth. Correct? I mean, okay. Last class, the one which I told you, it is an assumption which is very close to the structural point of view when you go for complete loading system. Okay, these are all our experience. Okay, forget about the experience. Now let us talk about only the codal perspective point of view. Okay, the codal perspective point is what actually as per American code ACA 318. Okay, so when you want to go for simply supported, what is simply supported beam actually? There won't be multiple span of that beam. Okay, only one span beam, which is single span beam. Two columns, the beam is supported on top of it. So when you talk about simply supported beam, the depth is what? Span by 16 actually. When you talk about one end continuous, what is one end continuous actually? So my span is there actually sink from the edge which is stacking out. So I have only one edge continuous. Okay. If you talk about both end continuous, so you're talking about middle span of the beams, then both sides you have a continuous beams. Okay. So it's all there. Span by 18.5, span by 21, cantilever of course span by 8 because that is very critical. You get my point. Okay. So I'll move forward. The L is what? The clear span between the supports. Okay. What is span? The span is actually, it's not the center to center distance of supporting elements. It is a clear distance, which is a clear span. Okay. So what is a clear span actually? If I do have a columns of 200 by 600, 200, so I don't take it the dimension of the columns. So from the face or inner face of the column to inner face of the column. That's where the span is being describing that actually. Okay. So let's go further actually. Okay. So the slab thickness here we are assuming as simply supported. Okay. So span by 16, which is 12 meters because the one which you are talking about it's a bigger span. Okay, 12 meters. So 12 by 16, if you talk about actually you are getting 750 millimeters. Okay. So the area of the reinforcement, if you talk about, okay. This is the common equation for the area of the reinforcement. The moment divided by 0.95 of course. This is just for understanding. Okay. Let's talk about in detail calculation what it is. Okay. So when I go here further, so this is what that beam is replicating. This is what the beam is replicating. So how does it is both end fixed support, both end it is a fixed actually, and this is how the moment is going to be distributed. When you do have both end fixed actually, when you do have UDL on top of it, then the negative moment will be WL square by 12. Okay, the positive moment will be what? WL square by 24 inch. Okay, I'll move forward. Okay, then the load calculation comes. Okay, so when you see the total ultimate load from the slab, okay, total ultimate load from the slab, you need to give me like 2 minutes. I will just shuffle the paper. Maybe the papers is being shuffled up. Maybe confused actually from the document platform. Give me 2 minutes. The papers is being shuffled. मुझे ना ये कनेक्ट कर दो ना मिस्टर शायद मैं उधर खड़ने का जरूरी नहीं इधर ही बैठ जाता हूँ स्लैब Okay. Basically, it is same actually. The one which you have seen, the first one is beam design. I don't want to go directly to the beam design. Let's focus on slab design first. Then we'll go for beam. Then we'll go for column. Then we'll go for a foundation. That is where you need to get this one. If I go directly beam design, then you will not get very clearly for the loading vertical calculation. Okay. So we'll go directly for the slab design. Okay. So as I said, the panels is what actually 12 meters by 7 meters. Can you see the panel? The bigger panel, right? 12 meters wide. 7 meters, isn't it? Yeah. Okay. So this we already discussed, right? 5 by 6.75. This is the influence area of the columns, correct? Yeah. Okay. We're going to focus on this slab, the bigger spannage. Okay. So I'll go down. The influence area is what actually. See, for the beams, you could see what do you call the loading, half of the span, half of the loading which is going to be transferred to the beam, right? Actually, okay. Slab, you could see one-way slab or two-way slab. Okay, one-way greater than one-way slab. If it is less than or equal to two-way slab. You get it? Okay, that's two-way slab. Less than or equal to which is two-way slab. Or greater than two, it is one-way slab. What is one-way slab? Anyway, what is one-way slab? It should be the load is going to be distributed what we call half of the beam. Okay, this is only longest layer of the beam. The one which you call the columns mainly in order to calculate the actual load on the column, it is very generic, very typical. Though you do have a frame system, though you do have a flat slab system, doesn't matter actually. The column influence with this influence line diagram is what actually adjacent to the column half of the span, adjacent to the column half of the span, adjacent to the half of the span which is like in y direction actually. Those exactly the half which are calculated, that is the dimension which are going to be length and width, correct actually. This is we used to call technically it is influence line diagram. Actually, it is called loading. You get my point. It's called loading zone. If you're not comfortable with influence line diagram, the wording actually call it as a loading zone diagram. Loading zone diagram. Okay. So let's focus on the loading calculation. This is extracted from DBC by building code. Okay. What does DBC code mean? When you go for lightweight block wall, lightweight partition, lightweight blocks, A.A.C.C block. Remember, there are two kinds of blocks in there. One is hollow blocks, another one is A.A.C blocks. If you go for A.A.C blocks, including the finishes, the load is what? 4.5 kPa. Okay. When you go for a hollow block work, which is 5.5 kPa. When you go for drywall, you know that, right? It's all gypsum partition. Whatever you do have, it's all gypsum partition. Okay. This is gypsum partition, which is 4 kPa. Okay, so when you go for live load, this is extracted from A.E.X.L. Okay, so for residential building, it is 1.92, but in general, we used to take it 2 kPa. You get my point? Though it is decimal, but we don't go for a decimal, which is 2 kPa. Okay, now going with the minimum thickness of 2A slab. How do you say it is 2A slab? As I said, Ly by Lx, longer span divided by shorter span. The ratio between longer span to shorter span, if it is less than or equal to 2, it is called what? 2-way slab. What is 2-way slab? All the direction of the beam is going to take the load. Okay. In 1-way slab, it is only one direction of the beam which is going to take the load, which is one direction in the longer span. Okay. Shorter span is only giving the what do you call effective length. To break the effective length of the column, it is only giving the support condition. Okay. So let me go for it. If you go for like what do you call minimum thickness of 2-way slab without drop panel, assume what is drop panel actually? This column capital, right? From slab actually only at the column location there is like square or rectangular, it will be projected outwards. Okay, if you see most of the things in car parking basement, you get my point there. Okay, so now let's go for like without drop panel. I don't have drop panel, it's only clear cut of slabs. Okay, in such case the FY is what actually these are all yield strength of steel 40,000, 60, 80,000. These are all in PSH. You get my point? These are all in PSH, which is equal to what? Which is 420, 460, and more than 500 H. You get my point? This is the yield strength. When you go for without edge beam, with edge beam interior panel, there are three kind of things. So without edge beam, actually, this is we are talking about like edge panel. Okay, the one which you're talking about, the similar panel. Okay, so that is span by 33, span by 30, span by 37, span by 36, span by 33, span by 30. So this is related to with edge beam or without edge beam. Okay, so I'll go here. So ours is actually with edge beam, which is span by 36. So the slab thickness has been assumed span by 36, which is 12 meter. Okay, so 12 divided by 36 is how much? 333 millimeters of slab thickness, because the slab panel is quite big. You get me? It's almost 12 meters span. So, however, we are not going for like 333. We will consider like for optimum case, we will only go with for 300 millimeters. You get my point? But though you are going for 300 millimeters, you need to check whether the slab is safe under the moment, whether the slab is safe under shear, whether the slab is safe under deflection. Everything you need to make sure, because you reduce your thickness, correct? Isn't it actually? So let me just go for the area of the reinforced is the same equation. Moment divided by 0.95 F1 Z. Z is what? Lever average. Okay. Don't confuse. I mean, like we'll go for the. So what is this terminology? MU is what actually factored moment. Anything when you're going to design the structural element, then you have to consider with factor of safety. Okay. That's called factored moment. Factored moment is what? When the load is like multiplying with the factor of safety, it is called factored moment, because factored from the factored load you're calculating moment is called as what? Factored moment. You understand, no? So the yield stress of steel is 460, and this is the lever arm. The lever arm equation is 0.89 multiplied by D effective. Okay, what is D effective? D effective is what? Last class I told you. Overall thickness minus the clear cover minus half of the bar diameter. You get my point, okay? So overall thickness. Assume our overall thickness is what? 300 millimeters, correct? What is the slab cover in general? 25 millimeters, isn't it? So 300 minus 25, 275. Okay. In general, yeah, here is there, right? Yeah, fantastic. Yeah, fantastic. I have given, right? See, clear cover plus half of the. This is called effective cover. Okay, effective cover. What is clear cover in slab? 25. In general, like for slab diameters, we'll go for not less than 12 millimeter diameter. Even as per code, actually, according to the code, it should not go not less than 12 millimeter diameter. Okay, the main rebar actually. So half of the diameter is what? 31 millimeter. This is called effective cover. When D effective is what? Overall depth minus effective cover is called what? D effective. It's clear, right? Okay. So let me go further. The factored moment actually for the corner panel. So since it is an H panel, I'll give you the separate tabular column. To shows what is this equation. Okay, what is this equation? It's very clear. It's very easy as well. Okay, there are only 4 or 5 equations are there. This is not going to get changed. The WLS square. Only these factors is going to get changed. You get my point? Only these factors with respect to H panel, with respect to interior panel, with respect to corner panel. Okay, only these factors is going to get changed. So for ours is what actually corner panel, because there is no slab continuous further in the left hand side. Correct actually. So 0.057 actually. Don't bother about this value. I'll give you separate actually. Okay. So when you do it actually, like then you will get what 50.83 kilonewton meter. This is what moment. Understand? No? Yeah. Then I'll go further. What is the factored load actually? 1.2 dead load plus 1.6 live load actually. What is like what do you call this 18.2 only, which we do have substantiation. Okay. So 1 point, what is dead load actually? 7.5, the one which we calculated before, and 5 is what? Can you see? Yeah. Yeah, here. The self weight of structure is 300 millimeter thickness multiplied by density of concrete, which is 7.5 kPa. And the SDL, just now I have shown, as per DBC code, which is 4.5 kPa for superimposed dead load. 0.5 is what actually, including the false ceiling and finishes. You could see as per DBC code actually. Apart from 4.5 kPa of superimposed dead load, including finishes, there is 50 kg per square meter for suspended services with ceiling as well. You get my point. So totally, which is together what? Together 5 kPa. Okay, the live load is, as I said, actually 1.92 kPa, right? Actually, okay, that we used to consider normally 2. We don't consider as a decimal level. Okay, that's 2. The span is what we are talking about 7 meters, because the equation itself, which is L(x) square. Okay, L(x) square, which is 7 meters. So the one moment when we substantiate, you will get like what 50.83 kilonewton meter. Okay, then I'll go further. Yeah. Interior panel. Okay, this is called what? Interior panel, just for your understanding actually. The one which you have seen for corner panel, this is for interior panel, the two set of factors actually. This terminology, it remains same, WL(x) square and WL(x) square, it remains same. Only those factors is going to be get difference actually. Those factors I'll give you separate code extraction as per ACA code, ACA 319. Okay. So I'll ask them to give you what you call the couple of factors actually. So only by substantiating is what actually these factors are. But remember, whenever you used to do for two-way slab, so you will never take it longer direction reinforcement. You get my point. So all the moment which you used to calculate for with respect to shorter direction, L(x) square. So don't confuse yourself. The only difference is what I mean when you're talking about one-way slab to two-way slab, for a better understanding, which is the ratio between longer span to shorter span, if it is less than or equal to 2, it is called what actually two-way slab. When it is greater than 2, it is called what? One-way slab. That's it. And other things actually, it's all related to what? Shorter direction span. Okay. If you confuse, then in exam point of view, first will go actually. Okay. So please focus on an exam point of view, because this is where the people used to do mistake actually. Out of 26, 27 questions, I mean, you can just have a choice of leaving 2-3 questions. Other than that, everything which will directly, because now I remember the passing score is what actually more than 75%. Before it was 70%, I mean, now they just increased to greater than what do you call, more than 75% of passing score. Okay. So going with the reinforcement, which is the same similar equation, I mean, the one which you have seen the earlier. So moment divided by 0.95 FO is that actually the moment which you already calculated 50.83. Yeah. Only substituting the value, you'll get what actually 547 millimeters square. Okay. Now, as I told you, as per code, the rebar diameter should not be less than 12 millimeter, which I'm talking about the main reinforcement. I'm not talking about the shear reinforcement. In slab, you don't have any shear reinforcement except the punching shear layers. Okay. There won't be any kind of shear reinforcement. Even both the direction which you talk about, it is all main reinforcement only. Okay. The shear reinforcement comes only to satisfy the punching shear, to satisfy the shear. Either it could be one-way shear or two-way shear. This is completely related to shear calculation. Other than that, I mean, you're only focusing on what do you call the main reinforcement with respect to the moment. Either it could be called as positive or negative, doesn't matter. I mean, but to satisfy the bending moment, you need to have a rebar. You get my point? Those rebar, according to the code, it should not be less than 12 millimeter diameter. Okay, so the T12 at 175 mm center to center, you'll have the area, so you know how to calculate. Per meter, actually, you'll go for 175 millimeter spacing. Okay, though the span of the slab, though the dimension of the building, okay, if it is like, more than 10, 12, 20, 30, 40, doesn't matter. So we are going to design per meter width. You get my point actually? Because the walls and the slabs, the designing is based on what actually per meter width. Other than that, we directly focus on the element shape. Okay, whatsoever the dimension. Say, for an example, beam, will only directly go for beam dimension. But only for the slabs and walls, we'll take it as per meter width. So we'll design per meter width. Whatsoever the reinforcement which is going to become, we will just, what do you call, lay down completely for the entire slabs. Either it could be like, 20, 30, 40, doesn't matter. You get my point? Okay. So the first check is over. Though we have reduced the slab thickness, which is demanding 333 millimeters, we went to 300 millimeters for optimization. In calculating this 300 millimeters, we consider the load according to the DBC and the American code, and we end up with the moment, and we end up with the, what do you call, reinforcement check. The second check is what actually? Shear check. Is it clear? Okay. The shear check is what actually, since we assume it is simply supported, which is WL by 2. W we know that actually 18.2. This is factor load. Huh? Remember, it is a factor load. Okay. So WL by 2, the L is what? Shorter span, about 63.7, and here there is a substantiation. Okay. What is the shear capacity? Which is 0.17 root of FC prime. Called as FC prime, FC doesn't matter, but this terminology is called as what? Cylindrical strength. Okay. The difference between the cubical and cylindrical is always 20% lesser than the cubical. Don't confuse yourself, huh? Because this is also like, one of the question which always the people trying to confuse by themselves. I mean, like, people giving the marks in the examination. You get my point? Okay. So very basic, I mean, but assume in a such a way that actually 20% less when compared to what actually cubicals. Okay. If you want to have a better understanding, I mean, the cubical will be 150 by 150. You get my point? The cylindrical is what? 150 mm diameters. Since the surface area is less, automatically the compressive strength of concrete is less. Okay. That's the reason this 20% is play a vital role. Okay. And shear capacity, such we are going for like, this is the equation 0.17 root of FC dash B into df. This is what? This is the one-way shear. Okay. This is the one-way shear equation. Where the one-way shear equation will apply? Shear wall, slabs, and beams. These three elements actually one-way shear equation will apply. Okay. There's only one case is actually two-way shear equation will apply actually. Slabs you will have both. Okay. You'll have one-way shear and two-way shear. Two-way shear, it has been like, what do you call, participating when you don't have beams. You get my point? Okay. When the slabs is supported by the beams, then only one-way shear is going to be governed. Okay. When there is no beam, then directly two-way shear is going to be governed rather than the one-way shear. You get my point? Very clear. Two-way shear I will focus on like, foundation design, then it will be more understandable. Okay. So remember this thing, when the slabs are connected to like, what do you call, beams surrounded, it's only one-way shear is going to be governed. Okay. Then yeah, deflection check. Yeah, deflection check. Since it is a fixed beam actually, the fixed beam deflection is what? WL by 4, that will be 384 EIH. Okay. So WL is what actually, you'll have the span 7 meters service loop. Yeah. When you're talking about the deflection check, you need to go for what? Serviceability check. The design is finished. Design is finished till where actually? Till the moment until the shear, design is finished. Okay. So whenever you're going to do the further checks actually, then you have to go for what? Serviceability check. Because this is your purely checking the structural stability of the structural element. You get my point? Okay. So what is E 4700 root of FC dash? Okay. FC dash actually, as per code, I mean, the cubical strength should not be less than 40 grade. Okay. Any kind of structural elements, you should not go for not less than 40 MPa. If it is 40, ultimately cylindrical strength is what? 32, because it's 20% less. Okay. Then moment of inertia is what actually, that BD cube by 12. B is 1 meter. D is what actually 300, correct? So which we got it like, what do you call, 0.00225 m cube. So we directly like, substitute this value, you're getting 1.51. What is the allowable deflection span by 240, correct? Which is 29.16. The people is making like, lack of understanding in what? all those checks they will carry out by using shorter span. Okay. When it comes under deflection check, actually, what they used to do, I think like sir, both the span has been like would be called deflecting, right? Actually, then I'll take it like for a bit of cushion, I'll go for longer spans. Understand what I'm trying to say? Actually, longer span. It's completely wrong. You get my point, actually. So you need to go with the minimum demanding of allowable deflection. When you go for 12 meters, 12 meter divided by 240, then my allowable deflection is much higher. Okay. When you go for 7 meters, the allowable deflection is lesser. You cannot compare for the longer span. Definitely longer span is deflecting, but before deflecting the longer span, actually shorter span will be deflecting. I'm going to ask you a question again. In two-way slab, now you understand what is two-way slab, right? In two-way slab, you do have 4 layers, right? Bottom 2 layers, top 2 layers, isn't it? In Dubai, I mean, this is how we used to follow the reinforcement of the slab, isn't it? Whatever you say is B1, B2, T1, T2, right? Okay. Assume I'm going to have a shorter direction, longer direction, and top longer direction, shorter direction, correct? Okay. Let's focus on the slab at the bottom, actually. Which reinforcement you will lay first? Which direction of the reinforcement you will lay first? Shorter or longer? You get my point, huh? You understand my question, right? Focus me, huh? You understand my question? Very basic. Now I'm not going to degrade yourself. It's very basic. Okay. Two-way slab, you do a 4 layers. Bottom 2 layers, top 2 layers. Correct. Bottom you do call it as actually B1, B2, top you call it as T1, T2. Doesn't matter. Okay. Which direction of the reinforcement am I going to lay first? So many slabs we have seen, actually it has been like they call break in a piece of pieces in the slabs. So many buildings we have seen because of this blender mistake, actually the slab has got directly cut. You get my point? Okay, this is a very basic. I won't say like because I don't want to degrade yourself, actually, but the people even site experience who has been there 3, 4, 5 years experience up till now, actually most of the people they don't. Okay, only they used to see the drawings. Why are you looking at the drawings? If the drawing is mistakes, what you will do? You get my point? Okay. To know this, you don't need to know like what do you call by hearting like 50 equations. Okay? This is very basic. What I ask, which direction of the reinforcement to be lay first, right? Which direction of the span, by considering you've been like calculating almost what is that? Get my point? So you need to lay first the shorter direction. Then you have to lay first for longer direction. You understand? No? If you make it in the reverse, longer direction first, shorter direction second, actually the slab will directly deflect. The shorter direction is the one actually which is going to be carry the longer direction reinforcement. Because my movement is completely based on what? Shorter direction. You get my point, actually. Okay, this is where you need to understand the site experience to the design. Okay, the people who are having the site experience actually, which is really fantastic. They don't have it actually. Try to gather some more site experience. Go there and get it actually. Try to understand. For that you don't need to be stand in the site. You get my point. Okay, go there and try to understand and kind of things. Okay. I am saying actually you cannot be there in the site actually. Of course, if the girls are there actually, they cannot be always standing in the site, right? Actually. They used to always prefer to the office jobs. Okay, office jobs is what several QS, QAQC, technical coordinators, structural engineers, isn't it? Okay. In that case, without having the site experience, actually, there will be a lack of experience, which you could not able to what you call realize what it is in terms of design. You get my point? Okay. So this is where you need to focus what is. If you are more strong in the design, actually, then it's very easy, to get it what it is happening in the site. Okay. If you are more strong in the design. Sir, I'm more strong in the design actually. So what do you mean? I mean, do I need to buy heart the equation for 50? No. You need to understand the core concept. Till now, I did not even talk about anything what we call about the equation. We only spoke about 2, 3 equations, right? Actually, it is all related to concept. The moment when you don't understand the core concept actually, plus. You get my point actually. Don't focus. The design is meant for the formulas and as well as like what do you call equation. The design is meant for only the core concept. The moment when you understand the core concept, I mean, so I'm telling you like what do you call you been like completely and which you can easily compete the experienced person of the structural. Okay. As I told you again the last class, the person who has 15, 20 years experience, you only have 4, 5 years experience in the sense actually does not mean I mean the 15, 16 years experience guy which he can do like the complete proper design. Okay. Even this 4, 5 experienced person, he can easily competent when his core concept is much stronger than this experienced guy. For that, you need to all build your core concept. So whatsoever it has been there, try to understand in terms of concept words. In terms of like, what do you call, observe in terms of concept research. Imagine, and if you do have a couple of questions, ask no research. Ask yourself which. If you don't get the answer, actually, like, ask me no problem. But try to like, what do you call, ask more questions. Why it is built? I said like, what do you call, the equation which is based on WL square, right? WL square. Nobody asked the question, why it is WL square? Why it is not WL square? Why it is not longer span? Why it is only for shorter span? Isn't it? The ultimate thing which I wanted to clarify this, the reinforcement which you're going to lay at the side, the shortest side. So this is what the whole concept, which is right behind all the equation and all the, what do you call actually, empirical formulas. Okay. Formula XYZ, whatever it is actually. I don't want to buy that, keep it in the paper actually, keep it in the tab, keep it in the mobile. But if you don't have core concept, what is the equation? What is the purpose of like, to have this equation, the by hearting in your mind? Get my point. So all related to like what actually try to understand the concept wise to make it very deep. Okay. You get my point, right? I'll give you 5 minutes time actually. Okay. Try to understand. I mean, if there is anything you want to write it actually. I'll try to arrange the study material, how you do circulate last. I will take a break for 10 minutes actually. So it's better like at least you can focus and you can just gather the points, the one which we discussed for the slab design. Yeah. Just take a break for 10 minutes and whoever want to write something very important notes, you can write it. Okay. Okay. Put the cleaning. So equation and focus. One minute. 21 meters. Those things. So you're into scaffolding design again, and you're into steel structure. Steel structure. So the web is we discussed the 2 hours for the value feature. Yes, I remember. Yeah, I saw the already shipped to the outfit. Outfit, yeah. 48 or 52. 52. 52. They engage A.E.X.L in order to dismantle and in order to erect it. They engage a separate specialist. Yeah, we're using the strand channel catcher. Like, that's bad. Yeah. It's all assuming in the air actually. Push from inside, push from the outside fall assuming. I think he's already in the print of the bill. Okay, yeah. Once it's done, it will have it done. Okay. So will get the yeah, I think. When you start the computer? When you start, we just go for manual calculation first. Then select the we'll go for beam design. In continuation to the slab design, we'll go for what? Beam design. So looks here, this beam is like, what do you call 12 meter length. Yeah. And these are all like, what do you call 2 meters, 6 meters, 4 meters. The maximum span which are getting 6 meters. Okay. So let's focus on like, what do you call the biggest span of 12-meter length. Okay. So this is what actually to be like, what do you call an initial assumption in order to calculate the beam depth as per American code, which is ACA 31819. So the minimum depth for non-pre-stressed beam, which is like, cast sensitive beam. Okay, simply supported span by 16, as I discussed like, earlier, the span is what? It's a clear span, okay, from the inner face of the columns to inner face of the columns, okay. So the slab thickness, yeah, this is called beam thickness. Huh? This is the beam depth. Okay, span by 16, which is 750 millimeters, and the area of the reinforcement. These things does not going to change. The only thing is what do you call effective cover is going to change, because effective cover, the clear cover in slab is 25 millimeters, but the clear cover in beams is what? 30 millimeters, 3 centimeters. Okay, the rebar which you have assumed in the slab is 12 millimeters. But the rebar in the beams, the minimum diameter is what? 16 millimeters. Okay, that is the only change, 38 millimeters. 750 minus 38, which is 712 millimeters. Okay, and this is what assuming a fixed beam. I mean, okay, we'll have like two equations. One is for positive moment, another one is for negative moment. The positive will be WL square by 24, negative will be WL square by 12. Okay. Total ultimate load. This 18.2, you know that, no? Okay, we discussed in the slab in continuation to this. And what is this 12 plus 7 by 2 actually? Because the moment when you talk about this span, since this panel is what actually two-way slab, correct? Okay, when you talk about two-way slab, the load which get distributed as trapezoidally. Okay, and you see trapezoid. What is the trapezoidal area formula? A plus B by 2 in which? What is A? 12. What is B? 7. What is actually H? Actually, I believe it is 3.5 meters because it's 7.7 meters. Half of is what? 3.5 meters. So let's go here. So that is what here. So A plus B by 2 into H, which is 3.5. Then if you multiply, you will get what in terms of kilonewton. But in beam, which you are going to apply the load in terms of what? UDL, kilonewton per meter. Okay. So if you want to convert into UDL, so what is the span of the beam which you are going to design? 12 meters. So if you divide by 12 meters, you will get 50.42 kilonewton per meter. That is called UDLH. Okay. So the moment is what? There are two moments which we have discussed already. WL square by 12, WL square by 24, which is substituting the value, you're getting 605 kilonewton, 302 kilonewton, which is the support, which is negative moment, which is positive moment. Okay. Area of the steel is what? Which is the same equation, only substituting the moment value, and you are going to get 2184.9 millimeter square. To compensate this 2184, I mean, I'll go for like, the rebar. Say, assume if I'll go for like, 5T20 instead of 25 millimeter, if I'll go for 20 millimeter. What is the area of 20 millimeter? Pi d square by 4. Okay, pi d square by 4. If I go for 25 millimeter, the 25 millimeter area is what? 491 pi d square by 4. Okay, so 5 into 5, 491, which you will get 2455. So what is the required is 2184, which is safe. So going with the area of the reinforcement, because you do have two moments, right? Actually, one is support, one is at the middle level. So the middle moment is what? 302.52. Then when you substitute, you will get 1092.66 actually. Again, so I don't need to go for 5 numbers of the bar actually. So I can reduce the bar because the required area of the reinforcement is lesser than the support reinforcement. You get my point? Okay. What is this equation? This equation is according to the ACI code. I mean, the minimum reinforcement, any kind of structural element actually. Okay. Sometimes what will happen? Sometimes the moment which is indirectly proportional to area of the reinforcement will govern. Okay, when compared to the minimum required reinforcement. Sometimes what will happen? The load is much lesser. I mean, the demanding reinforcement is much lower. In that case, I cannot go for like demanding reinforcement. I have to go according to the code. What is the minimum required reinforcement? According to the code, this is regardless of the load. Okay, regardless of the load. What it is actually, there are two equations. One is actually 0.25 FC dash divided by FY BD. Another equation is what? 1.4 divided by FY into BD. There are two set of equations. Okay. So though whatever you do, you need to use this two set of equation actually, calculate, and the provided reinforcement, it's supposed to be less than this. You get my point? Okay, yeah, you get my point. So going with the should not be less than, this is what the provided rebar. The provided rebar according to the moment, according to the calculation of the rebar, should not be less than the minimum rebar as per the above equation. Okay. And going with the shear check, it's the same equation, WL by 2. W you already calculated factor load 50.42. So 12 divided by 2, 302.52. And the shear capacity, this is again one-way shear. As I told you, right? Actually, okay, it's the same equation, one-way shear. And when I substitute the value only for the grade of concrete and width and depth, you'll get 171.17. The allowable shear is what? 302.52. Okay. And the required shear area of the reinforcement. Now, this is what? This is the allowable shear. 171.17 is allowable shear due to the grade of concrete. Okay. What is your actual shear? 302.5. In such case, there is a deficiency, right? There is a deficiency. How much deficiency? The deficiency is what? VU minus VC. VU minus VC is a deficiency. You get my point? So I need to calculate the shear rebar, whatever the deficiency is there actually to compensate. What is the shear rebar? In the beam actually it is a stirrups, ties. You get my point actually. Okay. So those ties equation is here. which is VU minus VC 5. This is not pi, 5. Okay, which is a reduction factor. Fy into S. Okay. The actual shear force is 302.52. Allowable shear is 171.5. Reduction factor is 75, which is 0.75. And Fy, the spacing I'm assuming, because you know that, like, in constructability, spacing is what? 100 millimeter, 125, 150, 175, 200. Nobody go more than 200 millimeter spacing between the reinforcements in general, as per the constructability. But what is according to the code? Actually, according to the code, it should not go more than 300 millimeters. More than 300 millimeters. So all supposed to be less than 300 millimeters. Okay. So when you calculate the shear area of the rebar by using this for the deficiency, which is only 10 millimeters per meter, which is much less. But however, I'll go for, like, what do you call, actually, the provided rebar is T10 at 200 mm center to center. Okay. Because the diameter of the steel is 25 millimeters. Okay. So compatible with diameter of the rebar, I cannot go for 8 millimeters. Okay. So I have to go for compatible, or else the bar will not be locked, will be open practically. Okay. Then going for the deflection check, again it is a fixed beam. The same equation, only the substituting the value for serviceability load. Okay. The span of the beam is 12 meters. And if I substitute this, actually, you will get what I mean? You will get actually 9 mm. Then what is the allowable deflection? Span by 240, which is almost 50 millimeters. Okay, because this is only talking about the particular span, 50 millimeters. The actual deflection is what? 9 mm. Okay.
So for the beam and the slab, both are the same equation.
For the deflection, yes, it is same, because for the fixed beam, if you talk about simply supported, then here the 5 will come. 5 WL4 by 384. That's it. Since it is a fixed, actually, the 5 will not come. But for shear equation, everything it is same. Okay. Moment, shear, everything is same. The concept is different. Okay, this is what I told you. Don't go directly with the equation. Okay, only the concept is different. If you try to understand the concept, actually, three equation, and if you write it like 3-4 times, automatically it come. You can easily, like, deeper go through this. I'll arrange different. I'll arrange.
Yes. Second address finish. Second year. Yes. Yes, in college. Yeah. Manipal University. It's in A.E.X.L. A.E.X.L. It's Dubai knowledge. What you know, what you company? You drive?
Yeah, I tried.
No, you need to take care of that online class. You'll actually save a lot of food. Maybe you will feel fresh in the Sundays. Like that morning you will come to the bar, you will have a shopping. That's good. Where do you concentrate? As a supervisor or as a PG? Have you done your bachelor's? Yeah. In Masters. Both in Philippines.
I'm Chinese also. And I did my bachelor on cooking.
You have done ATF also.
Right.
Nice.
Nice.
So have you been into any projects or works and how we different this the actual site.
The concept actually.
Yeah.
It's quite different, especially when you do a site on the site, you know, that very clear about the only box all those results. Because still work after this.
What's the name?
E. Like
Manjunath.
watching it's from
Yes. India actually Karnataka. It's a state in the southern part of Karnataka. It's a southern part of the India. Southern part.
I think the middle source.
It's like you might know Mumbai. Mumbai. Like you know Bangalore. Yes, and the same city, but in the city, it's a different city. And I'm pretty sure you're from Beijing. Of course, there are a lot of cities in China. Maybe I know Beijing, Shanghai. Shanghai is a city there.
Yeah, Shanghai.
Wuhan and Wuhan. Of course,
The coronavirus come from there.
because yeah, it's famous at that time that people got to know about this. Yeah. How developed is China? How developed is China? It's a way to develop. Like in social media, I see it's so technologically advanced.
The our government is kind of close. You know, we got the some
Yes, yes. And you don't have YouTube, Instagram, no, yeah, especially.
all the followers.
I wish something like India would do that. We're not that advanced.
Your comment.
Nice. So you're which city in China? Which city?
Actually, it's in 0.5.
But not too much about Chinese geography.
It's fine.
How is studies in UK? How is studies in UK? Like other national methods?
There to study certain people. Actually, they do very beautiful university. Nice. This one is very nice.
My specific plan is to like get degree from here and even my master's here, work here. This get a good visa here. Maybe I will get a very good job also. It plans to have a really good job over here. Just checking out any of the companies, internships. I have checked more than 5 companies, but I didn't get into that. So I just looked for like in my second year of my degree. So like they said like in this year, this holidays you have to join any company. So like join the company, work with, get knowledge from it. So I have no option. Like I just checked with the companies, but they all didn't give me a plan. So then afterwards, all my weekends, all my weekdays, I'll be like with my father. My father also has where he's we have a fit out company. Fit out in the sense we don't do many major construction like towers or buildings. We do like minor things like you might know interlock was interlock. No, interlock work means the ground, if we use the pavement areas, the stones, interlock stones, we have to keep on the sheer pictures.
So how many years you shoot on?
Like from my childhood, I was like second grade.
Really?
Yeah. From then, this is the word. Interlock. This is interlock flow. It's not a good video. So
Do you offer the material? I don't know.
raw material too.
I don't know. Which you can not function.
We need material regarding this interlocks.
Yes.
I think so. We can arrange it from one of our suppliers. We have a supplier for this interlock. So like, but I don't know about the travel cost. Maybe it would be really good if you will just check out the if it's in Abu Dhabi, then
Yes, no.
it's in Abu Dhabi, then traveling cost will be really more. Yeah. We have a supplier with yeah. Korea, so this is the specific work we do. Interlock, not only interlock. We also do some type of foundation work also. Like last time on my holidays, I went to another site where we have done foundation. So foundations do teach for. I'm 20. Yes, yes. I don't look like that, but I do. This is another foundation and plastic. So our company does the minor things like making a foundation. We don't build any towers or we have only 15 manpower. 15 manpower. It's again. We have 15 people, and then we have been involved from different sides. So, yeah,
I mean, nothing is very so many.
so I will get really good job. My main focus is to get a good job outside the first thing, and then is to get
The
more.
absence of the family is more possible.
Yes, that's why I'm checking. I was checking outside, but still I didn't got anyone after. But that's why I just went. What's the company?
Right? Functions, models, efforts, all the possibilities from us.
I mean, sure.
ये close हो गया और एक
Company not device. It's a Chinese company. Who like majority of the projects are in China.
It's also
graphite.
Chinese or other? Chinese. You are the first person I meet Chinese. Maybe China or some other. But our classmate is Indian. Some other some copies. The column, slash, and last section. So
Okay, fantastic. We'll continue. In addition to what you call the previous calculation before we stop for the beam design, right? Now we'll go for what actually column design. Okay. So I wanted to show you everything, start from slabs, then go to the beams, then we'll go to the columns, then we'll go to the foundation. Okay. So now coming back to the columns is what actually, okay, it is again the same. Okay, these we already discussed, the influence area and everything. So I don't want to repeat it again. Okay, so these are all same. Going back here, it's what actually assuming it's G+1 structure. Okay, G+1 structure. Total factored load, this that because it is a continuation, correct? 18.2 kilonewton per square meter from slabs. Multiplied by this 33.75 is what actually, which is the influence area. Multiply by 2. Why it is 2? Because it is a G+1 structure. Because the bottommost column will take 2 floors. If it is 4 floors, then I will multiply 4. If it is 8, then I will multiply 8. Since it is only 2 floors, then I will multiply only 2. So 245 tons. 2457 kilonewton, which is nothing but what? 245.57 tons. Correct? Yeah?
Okay. Sir. There will be a separate A.E.X.L code because
A.E.X.L code.
I mean, A.E.X.L code.
Yeah, separate code is it. A.E.X.L code. You want that code, right?
And also maybe I want, because I regularly use the A.E.X.L code.
No problem. We'll send you the code.
So maybe some design or
yeah, please remind me. I will inform them actually. I will send them. They will send it to you. All ACA code. ACA 318, AC 7 actually. Whatever related to ACA code is there.
So no A.E.X.L code is used.
Not all actually. Even we don't use the British standard actually for the concrete structure. Okay, we only use American code. Okay, only for another code. Yeah. Okay. So coming back to here. The calculating the dimension of the columns. Okay, calculating the dimension of the columns. The gross area of the column. Now I'm going to calculate the column dimension. Okay, I'm going to calculate the column dimension. Okay. The column dimension is what? Which is respect to actual load. With respect to actual force on the columns, which is respect to applied load on the columns. Correct? Yeah. Three terminology both are same. So AG equal to PU is what? Ultimate load divided by 0.85 FC prime action. Okay, what is PU now? 2457 kilonewton because this already factored load. Okay, multiply by 10 to the power of 3 because you are converting into Newton. Okay, because this FC dash it is a Newton per millimeter square. So I'm keeping all the terminology is the same unit Newton by 1 square. Okay, and then I'm going to get the area is what actually 112411.76 millimeter square. Okay, so as per authority requirement, the width of the column should not be less than 250 millimeters. Reason why? Before they were accepting 200 millimeters. Nowadays, the authority minimum requirement of the width of the column is what? 25 centimeters. Okay, so again, note this point. Before they were accepting 20 centimeters. Now they're requiring the minimum width is what? 25 centimeters. Okay.
The authorities, which part?
Dubai Municipality, Tarkhiz, DD. Dubai Development Authority, the one which is going to be approved your design. Okay, assume you're the steel contractor. Assume you're working in the consultant. The moment when we finish the design, you will submit to them actually for approval, right? Actually, okay. So this is their requirement. Okay, so the proposed dimension of the column is what? 250 by 4. How do you got 400 actually? Because I know the area, correct? Actually, okay. When I divided by 250 and one side of column, then you will get other side of the column. Correct, actually. Because at the end, I need to compensate this area. Correct? Yeah? Okay. 250 by 400. You can go for 250 by 400 to carry out the calculation. But in general, for villa design, we used to go for minimum column dimension 250 by 600. You get me? 250 by 600. That's what we mentioned. Okay. If you want, you can go for it. Doesn't matter. Okay. But I'm talking about in general, we should go for 250 by 600. Okay. The column capacity check. Okay. The ultimate capacity of the column is something different. Okay. Something different than the actual. Actual loaders, you do have 2457 kilonewton, right? And this is the ultimate capacity check. Ultimate capacity of the column is what? 0.8 multiplied by 0.8 FC dash AST minus AST plus FY minus FY multiplied by AST. So we only need to substitute the value in order to calculate what, not to calculate the area of the steel, because I don't know what is the area of the steel. So far I calculated what is the applied load on the column, which is actual load on the column, and I know what is the grade of concrete, I know what is the grade of steel, and in addition to this I know the column dimension. Correct. Okay. But I don't know what, I don't know the area of the steel, which is area of the reinforcement. Okay. I'm substituting all this equation. I'm only calculating what actually the area of the reinforcement. So the moment when I substitute, I can easily calculate the value called what actually area of the reinforcement. You get my point, which is 1770 millimeter square, and 1770 millimeter square, which I'm just converting, will get like 10 to 16. Okay, 16 millimeter, the area is 201. So I'm getting 2010. Okay, then 1770 it is safe. You get my point? Yeah. Okay. I'm going here, shear check again. The same one. Huh? There in slab, we did a bending check, we did shear check, we did deflection check, right? Actually, here we did like actual capacity instead of like bending. Then we'll go for what actually shear check. The shear is what actually this actual force. That's a vertical shear, 2457 kilonewton. And the shear capacity is what? The same equation. How much you're getting? 144.25 is the allowable shear. The actual shear is much more higher. Okay. Then I need to find out what actually the requirement of ties, diameters and spacing. Okay. Then if I use this equation, how much I'm going to get it? 16.75 millimeters square. Okay. Then I'll go down 16.75. I'll convert into what? P8 at 200. The reason why you did not went for 10 millimeter dia, why you went for 8 millimeter dia in the sense, in beam the rebar is 25 millimeter dia. Okay, to compatible I cannot go for 8 because practically it will open up. Because if it is 10, it will catch up. You get my point. But here the main reinforcement is only 16 millimeter. Okay. So we went for what? 8 millimeter edge. Okay. Then okay. Yeah, this is where it is all related to what? This is all related to only the axial load on the column. There is no moment, huh? There is no moment. You understand, no? Only related to what? Axial load on the column. But the one which you're going to see further actually, it's called biaxial moment. What is uniaxial? What is biaxial actually? The column is rectangular. In one direction, any one direction, there is a moment. It is called uniaxial because one axis there is a moment. Technically, it is called what? Uniaxial moment. Both the direction, if I have a moment, it is called what actually? Biaxial. Okay. So biaxial moment is critical than the axial moment. Okay. That's what we directly don't want to take it like the moment what we call the manual calculation. We want you to understand when there is no moment actually, how do you calculate? When there is a moment, how do you calculate the what do you call column capacity? You get my point. Okay. I will leave it to you for 5 minutes actually. Okay. Just try to understand this. Try to understand this. Okay, understand this. I'll ask them to give you a printout. Then I'll go for biaxial. Yeah? Given. This is given. Now I will ask them to give you. No problem. I'll ask them to give you. Yeah. This is the slab. I'll ask them to give you no. Okay. But try to understand. I'll ask them to give you because I don't want to take it continuously. Because if I take continuously, then then you don't understand. You'll have time to ask the questions. You get my point. That is the reason what we used to do. We used to give you the hot copies. Go through that. Like whenever there is a clarification, questions, anything actually, you do ask. No problem. Okay. But otherwise, if you don't get what they call source, actually, you get my point. So I'll ask them to give you. Just go through that. Digestion. There's no way, huh? Digestion. So I only say digestion.
You understand?
Yes, some parts I don't quite understand.
Like this.
That design for the slab, when we have to consider the short span in the population. Understand?
Alex, like Alex, why we have to take Alex? You cannot stack by accident. I think like Alex, we find out we have to do the Alex because it will be much safer. Because as according to him, the LY or the longest span, it takes the shortest span will take the load of the longest. Goes like that. Like while the screen is placed in this case, and the short span is taking the load of this long span. Let's where is the formula for LX? For getting the LX, the one you said.
It's not in this picture, actually, it's in the slab, it's for big.
This is a slab. Assume slab.
Yes, yes, it.
Design. Slab design, it said this LX. Interior panel LX.
How about the slab? On the slab, will be one.
Slab. We need slabs. Slab. You're writing an exam. You're writing an exam. Yeah. No, like you're writing an exam. Like the exam is for this structure.
Yeah, I'll take the
Like engineer lessons, we have to write some code.
yeah, that's why I come. Increase myself.
Improvement exam.
All companies you count on that lesson increases. Yeah,
Okay, they said that you get that license. So it's a government exam. It's a government exam.
So what's your words to make up it?
Not actually, I'm not going to write an exam. My main focus is I know like the Indian standard code, I.E.X.L code, like issue.
So you know how you always start studying it.
Yes, like we have studied regarding design of columns, beams, slab, footing. Footing, yes. We have done this lesson, and this is one of this is how we say. This is the design of the
Yeah, that was your class.
it's
I think he's motivated.
actually it's old ma'am here. She was she said like first to find the depth. Depth means the thickness of the beam.
Yep.
Then the span, full span of beam. And then we have to find the moment of factor. So if the moment is under the limit, then it's a slave. Then afterwards you have to find the AST, area of slave retention. And then we have to find the shear, LCB. So one of the other formulas. And then we have to check it's a two-legged or so on the stirrups. And then we have to find the spacing. And then we have to show the drawings according to my teacher. So it's more detailed. But this is the only issue here is this is the Indian standard code. So this doesn't apply to me. Yeah, like
American code is applied.
yeah, American code is applied. And according to her question and her teacher, she is teaching with respect to the Indian standard. So like
Yes.
all we are Indian standard code, ISO, ISO. So in overall India, it's used ISO.
You're saying in China is our all code.
Yes, which ISO 456. I mean, we have this code potential. 6. This is our code. So in this we have all the formulas, or everything.
I think there will be not big difference. Maybe just the soft factor is like the equation,
Equation.
maybe you see different the sample. That's all.
Yes.
But the concept inside
Then mostly see. My main aim is to like first check out the Dubai standard and all of this.
yeah, that's
Yeah, I mean the AS, like the one used in Wing. And another reason is I want to learn the laptop, the drawings like one is like stack row and V tabs.
Yes, yes. I want to make that for tank.
I want to learn this things. This is putting. Putting, we have not studied this. Yeah, we have actually we have done this in our class. Like we have done another one. Putting was easy. Like we just need to find the dimensions. Then we have to find the shear resistance and shear.
Let me consider the first one.
Yeah. This is something different. Like what are we have learned. We have putting.
Start. ऐसा आप लेके जाते हैं मुझे ऐसा देखना फिर आप बैक का आपको दे दो बैक का சரி ஓகே நாளைக்கு கொடுக்க மாட்டேன் ரிப்போர்ட்டா ஷூரா சரி I'm from Chennai, South Part. You're from?
Karnataka.
Kannada.
Yes, sir. You know Kannada?
Tamil. Another guy also from Kannada, right? Kannada. Kannada. But he's also from Kannada, right?
He's Karnataka Manipal.
You are M.Tech or B.Tech?
I'm sir. I'm in B.Tech sir. B.Tech sir. Right now second year.
You studying?
Second year.
You studying? Which university?
Manipal University.
Here?
Yes. Manipal
Ah.
University in this one sir. Dubai Silicon
Fantastic. What your father is doing?
My father is actually having a company.
Yeah, you have a company.
Yeah, we have a fit out company. So like we all do every type of fit out work, like tips and partition, full ceiling, interlock work, everything. But main thing is my father pushed me to go into the structural work and design. And he said me learn about more about buildings.
Fantastic. Very good.
So my main focus and aim is all about the
Very good.
My main focus was on this.
Very good.
Next, this August I will be like playing as a third year.
Ah.
So now I'm second.
Very good.
So till now, sir, we have learned all about design, sir. Putting columns, beams, slabs.
Which university? Which code on it?
All in A.E.X.L code. So yes, sir. Like you have teaching me American standard, so it's a bit different.
Okay. Yeah. Coming back to the next one, in continuation to the previous. Okay. So for what we have discussed, we have seen the slab design, we have seen the beam design. Yeah. We have seen the column design. Yeah. Of course, we have been seen the what do you call column with the moment, right? Yeah. Okay. I'll go with the column with the moment. No worries, no problem. Because I jumped actually. Okay. Okay, this is with the column with the moment, right? Okay. So let me go with the column with the moment. This is what? Axial load plus moment. Same axial load. I'm not going to change it. 2457 kilometer, the one which we calculated. Since I don't have moment actually, we are assuming the moment. Let's assume the moment. The moment is 50 kilometer meter, 50 kilometer meter. This is the biaxial moment is very critical. Yeah. This is the biaxial moment is very critical. MUX 50, MUY 50 actually. Column dimension, remember 250 by 600, the one which we calculated. The total area of the steel is what? The rebar required due to axial load, 2457. The rebar required due to moment at X. The rebar required due to moment at YH. Fantastic. So the rebar required due to moment is what? Moment is 50, right? Actually. So when we do it, I mean, like, then you will get 237. And this is what D effective. D effective of the column is similar. 600. The column cover is 40 and ties generally will be like 8 or 10 millimeters, 8. And the main reinforcing you already did, right? 10 to 20. So 20 will be. Okay, but this is different. One is moment at X direction, and you've been taking like the 600. The moment at Y direction, you're taking like okay. Okay, that's what two reinforcement. The total area of the steel due to axial load, the one which we calculated before 10 to 20, this is 1770. And with the biaxial moment, how much you're getting? 237, 697, which is 2676 millimeters square. So provide 10 T 20 again, which is 3140, and the required is what? 2676. Okay, and it's not even finished actually. Still, the further check is there. What is that? The moment capacity due to axial load. Okay. So 3140 is your area of the reinforcement. Okay, which is this one? ASC equal to M by 0.95 FYZ. Okay, then I'm just doing the cross multiplication. I'm calculating the moment. So by substituting the value, I'm getting like 661.9. The axial load capacity, same equation, but I'm substituting all those things, then I will get the capacity is what? 4163. So instead of 2457 axial load, I will get 4163 because your dimension is much higher and your reinforcement is okay, but higher. So your axial load is much higher. The combined interaction is what? The actual axial load would be allowable axial load plus actual moment would be allowable moment in X direction, actual moment would be allowable moment in Y direction. Is supposed to be less than or equal to 1. This combined action, this is what is critical, which you need to focus on it. It's supposed to be less than 1. Okay. So what is the actual load? 2.57. No, this is called column. Column with the moment. Column with the moment. And this is the ultimate load, the one which we calculated. And these are all actual moment, the ultimate moment. So when you substitute, you will get what? 0.75. It's supposed to be less than or equal to 1. Yeah? It's clear, right? Okay. This is biaxial moment. Biaxial moment with the combined check equation. Yeah? Okay. I'll give you 5 minutes time. Go through this. Yeah? You have the hard copy, right? Yes.
It's actually 10 raised to 6. 10 raised to 6. 15 to 50 kilonewtons. So 15 Newton will be 10 raised to 6. Yes. Can you show me? Yeah. 50, 10 raised to 6. Maybe this 15 stick. And okay, same again. 10, 10, 16. 10, 16. Now 2, 0, and in this case, how many got this 201 and
area 16 millimeter. 5D.
it's 10 T means 10,
10 numbers.
10.
10 numbers.
Oh,
10 numbers. 10 numbers.
so it's like 10 numbers into 10 numbers of
River area.
10 numbers of speed and
So we can go for it, right? Yeah. Okay, fantastic. So this is what foundation design, right? Very good. So I'm talking about like what do you call the same column. We are talking about we are going to design this foundation. So this is in continuation to the previous what do you call modules for the slab design, beam design, okay, and column design. For the same column, we are going to design the foundation. Okay. Now I don't know what is the foundation dimension. So let's go down. The calculate actual axial load. You already calculated, right? 2457 kilo. Why divided by 1.4? Because we wanted to just know the serviceability loadage. Okay, serviceability. The lead load factor of safety is 1.2. Live load factor of safety is 1.6. So in an average, you can take it like 1.4 to 1.45. Okay, or you can take it 1.5 years. Doesn't matter. So this is what it is. It is a serviceability load without factor of safety. But this one is what with factor of safety. Okay, and the column dimension 250 by 600. Area of the reinforcement, same equation. Okay, then going here, what we call the calculating the effective depth. What is a clear cover? 75 millimeter. Yeah, for foundation. And what is the minimum rebar? 12 divided by 2. Effective cover is what? 81 millimeters. And assuming the depth of the foundation is 400, assuming 40 centimeters. Okay, I don't know whether it is right or not, but I need to do the couple of checks to ensure whether the depth of foundation is safe. I need to prove. You get my point, actually. Okay, and 400 minus 81, this is the effective depth. And calculating the foundation dimension. How do you calculate the foundation dimension? Stress equal to load by area, right? Stress equal to load by area. Okay. Now I need the area, then I will just what do you call cross multiply, which is load by stress. Correct? So stress, I'm assuming the SBC of soil is what actually 200. Okay, it's not 250, 200. Correct it? It's not 200, 200. Okay. So when we do this, you will get the area is what 7.02 meters square. Okay. When we do a square root, then you will get what you call actually the area of the foundation, which is 2.65 by 2.65. This is called foundation dimension. Okay, this is called what? Foundation dimension. This is what? This is the foundation dimension 2.65 by 2.65. And this is the soil pressure which is acting down on it. Okay. And this is the cantilever distance. Okay. So the column is what 200 by 600. In order to calculate the reinforcement, I need to see what is the maximum cantilever length. Okay. If I go for the 200, then I will get the what do you call the dimension here, which is 2.65 minus 0.25. Yeah. Column width is 0.25. Then divided by 2, which you will get the cantilever length 1.2 meters. Okay. Now I'll go here. A is T, area of the reinforcement. Okay. What is the moment? Moment is what? WL square by 2. WL square by 2 for cantilever moment. The cantilever moment equation is what? WL square by 2. What is W? I'm taking directly the SBC of soil. SBC of, because that is what the allowable SBC of soil. If I want to design, I have to design the same SBC of soil. I cannot go more than that. I cannot go less than this. Okay. So 250, what is the cantilever distance? 1.2 square divided by 2. Multiply by 1.5, which is the factor of safety, divided by, it's the same equation, 0.95 Fy Z. Then we are getting 1450 millimeters square per meter. Then provide T16 at 125 millimeter center to center. So 16 millimeter rebar is 201. 125 is what? The spacing between the rebar per meter, which is total 8 numbers. So 8 multiplied by 201, you're getting 1060. What is the required reinforcement? 1450. It is safe. And minimum area of the reinforcement for the foundation is what? 0.18% of BD. 0.18% of BD. This is as per code. Okay. So 0.18. What is BD? B is 1 meter. D is your overall depth, 400 actually. What is the minimum reinforcement? 720 millimeters. As I told you, it is not always the minimum reinforcement which is going to be like governed structural level. It's very rare case. When the load is less, the minimum reinforcement will go. When the load is more, actually, definitely the provided actual reinforcement is governed. The actual reinforcement is what 1450. Definitely it is more than this. What I provided 1660.
So what is 0.8 and
0.8? Where it is?
0.8.
Yeah, 0.89 is what actually is the lever. lever arm equation is what? 0.89 Z. 0.89 ZH. Which is, this is the lever arm ZH. Overall Z. The Z equation is what? 0.89 multiplied by D effect. Okay, this is what here. Can you see my equation? Here. Okay, can you see here? Z. The Z equal to what? 0.89 DH.
The effect.
Yeah, D effective. D effective is here.
Effective is the
Effective depth. Effective depth is simple, minus the effective cover.
so like total depth
Minus
the
effective
area of steel, like area of steel under tension at the bottom.
Bottom most actually. Not area of steel. Overall depth minus clear cover minus half of the bar. That's called effective depth. Clear cover is what? Clear cover.
Clear cover means like steels under steel there is a
Below steel actually.
below steel.
The one which you are going to keep the cover block, right?
The cover at the
Yeah, cover at the
cover at
before placing the steel, whatever the cover which you are going to keep, that is called clear cover.
that should be 25 mm.
No, that is for 25 mm for slabs. For columns 40. For beams 30. For foundation 75. Okay, it's all different. It is all according to the code. Not always 25. For slab is 25. For beam is 30. For column is 40. For foundation is 75. Because it is in touch with the soil.
So it needs more.
Yeah, because in touch with the soil. Anytime soil will have a sulfate, like chloride actually. Okay, then easily this cover is what actually in order to avoid the corrosion of the reinforcement.
So like the moisture might.
Yeah, definitely no, because the moment actually when the sulfate anything like
So
easily the reinforcement will get corroded.
when placing putting a foundation, they place
PCC.
They place PCC and also one plastic cover.
Plastic cover will be right below. The plastic cover will be first on top of soil.
Yes.
Then they'll go for PCC.
So one question, like why don't the concrete and soil should be mixed? Maybe
See, if you mix with concrete and soil, it will main reinforcement. Okay.
the footing.
Then what will happen? See, you can place it. Doesn't matter. You can keep it the foundation directly on top of soil
Without
Yeah, without polythene. Doesn't matter. But the problem is, what happened actually? Soil has different contaminants. Okay. Till to the setting point, actually, there is a moisture. Correct, actually. The soil will have a sulfur content. Okay. And if those two will be collide, actually, automatically, easily, will penetrate inside, the reinforcement will get corroded. This is you're talking about the reinforcement things. Okay. The reason why reinforcement you are providing in order to cater, in order to resist the moment, in order to resist the tension, because concrete is strong in compression, weak in tension. That's the only reason actually we are providing the reinforcement, isn't it? Correct. Otherwise, we don't need reinforcement. In general, if you talk about G plus one building, I'm only talking about the columns. You don't need reinforcement because column is compression member. Yes, I'm not talking about other element. Don't confuse. I'm not talking about slabs. I'm not talking about beams. I'm not talking about foundation. I'm only talking about the columns. The one statement which you said column concrete strong in compression, weak in tension, then supposed to be column is compression member. Okay, then you don't need reinforcement. Correct. However, we are putting the reinforcement in order to have long-term durability. Because there could be a climatic change will be happening. Okay, due to summer and winter, actually, concrete has two properties: one is shrink, one is expansion. Those two sort of things to control, I need the rebar. You get my point. It is very critical. It's clear, right? Yeah. Okay. Now coming back to this vertical. Yeah, shear, punching shear, two-way shear, because when the column is punch shear, okay, then the footing will be cracked this side, the footing will be cracked this side, and other side as well, the footing will be cracked this side. So all sides actually footing will be cracked. That's called what? Two-way shear. The two-way shear is also called as what? Punching shear. Okay. So actual shear force is what? 250 by actual shear force. This is the SBC multiplied by 1.2. Okay, which is the factor of safety, 300 kilonewton. The punching perimeter is what actually? The perimeter of footing. What is perimeter of footing? 2.65, right? What is this perimeter length? 2.65, 2.65, 2.65, 2.65. So that's what it's been like, you know, 2.63 multiplied by 4. Yeah, 10.6. What is the actual shear stress? Load by area. Right? What is the load? 300 kN, 10 to the power of 3 divided by the area. What is the area? 1 meter multiplied by the effective depth. Okay, that's the area. What is this punching? This is called punching area. Then you need to multiply the punching perimeter, punching area, which is 0.088 Newton per millimeter square. When you go for allowable shear stress for the punching, 0.33 root of FC dash. Okay, 0.33 root of FC dash will be 1.86 MPa. Then it should be less than this. Okay, because this is the allowable shear.
So concrete uses M30.
Concrete uses cubical is 40. Cubical is 40. Minimum concrete grade you have to follow for all the structural element. Cubical is 40 according to the DBC code. Then you can go for cylindrical is 32 because 20% is this. Clear, right? Yeah.
So that's one more thing in the concrete structure. How to determine it's a fixed end or simple support?
Yeah. In general, concrete to concrete connection, all are fixed.
All fixed.
All are fixed. By default, it is fixed. Only simply supported, which has happened in the steel. Cantilever. The steel, because steel, you can design the bolt in a such a way that actually the bolt and plate either I can provide the moment or not taking the moment, because that is a transfer. Steel failure is transfer. I can design the plate without having a moment. I can design the bolt actually without having a moment. Moment is what? Ultimately, it is tension. Okay. But concrete is a rigid.
Yes.
So rigid connection. You're not going to connect concrete to concrete by bolt. You're not going to connect concrete to concrete by plate. Concrete is monolithic axis. Okay. We are casting together. The rebar also, which is connected to the columns. So when it has been happening, such kind of things, it is called what? Fixed connection. Yeah, I'll leave it to you for 5-10 minutes actually. Was online student actually. Hope you got it, like, you know, what you call study material in a soft copy. We just go through it actually. So we covered the complete RCC module today. Okay, but only in terms of, like, you know, talking about, like, you know, columns. Still there. We do a couple of things, but I'm telling, like, you know, the basics, you know, what you call. We have seen, like, you know, slab design. We have seen, like, you know, column design. We have seen beam design. And we also, like, you know, what you call, see finally, like, you know, what you call foundation design. You could see in the columns actually we differentiated the one is considering the actual load, other one is considering, like, you know, what you call with the moment as well. Okay, so now you understand when there is a moment how to tackle it, when there is no moment, like, you know, what do you call, how to tackle it. Okay, so the critical thing is what actually when you do have a moment. Okay, and the more critical is what when you do have a biaxial. You understand? So just try to understand. Just go through it. Yeah. Okay, go through it actually. Digest. There's no other way I can say this. Digest. Because there is a bit of couple of equations there. I do understand. But don't focus on the equation. Try to understand. Again, I'm repeating the same statement. Try to understand the concept. Yeah, that's more important than the what do you call by hatting the equation. Yeah, that's it. Just go through it. I'll get back to you. Yeah.
But what about the spacing and
Yes.
spacing?
Spacing, yes. Spacing actually, like, you know, what do you call in constructability, as I told you, we used to go for the spacing is what actually 100 millimeters, starting from minimum spacing 100 inch. We'll never go for, like, you know, odd number 80, 90, 70. Okay, 100, 125, because I cannot give you 110, 120. Practically, it's different actually. You need to put yourself into the what do you call site peoples. Okay, as a design engineer, what the issues? Think in their perspective, whatever I'm going to propose actually, like site people can handle it. You cannot, because you need to put yourself into the site peoples. You know, who is going to execute the job actually? Do you think engineer, civil engineer? Who is going to execute the job? Foreman. Foreman is the one actually who is running the show. To be honest, so why should I hide it? Foreman is the one who is running the show. Right? Of course, you need an engineer because you need to guide properly. You get my point. But in data, foreman is the one who is running the show. So you need to put always what do you call wear the foreman's shoe. I'm talking in terms of like in a kind of perspective actually. So you have to make it an easy to understand a layman perspective. Okay. If I can give you 110 millimeter actually, he will swear on you. You will shout on you. Correct actually. What is the pointing out actually? Why he cannot make it like 100 millimeter? Why instead of making 110? 100 for him it is easy. He can mark it actually. 110 is a decimal. You get my point. You can also see, sir, 110 also easy. No. When you work on site, you will know actually. You get my point. Which is easy. It is not about like measuring the tape actually mark it. No. You get my point. So always try to give you the round figure. Sir, why I cannot go for more than 20 centi? Question correct. The thing is what? Again, who is running the show? Foreman and legs. Okay. They won't measure always like what we call 10 centi, 20 centi, 15 centi. Somehow what by eyesight actually the moment when they place for some of the rebar, by eyesight they can just place other rebar as well. They don't measure it for every rebar each and every. Okay, it's not possible actually, because it's a big cycle. Actually. Okay, it's not possible because slab to slab cycle you are going for 5 days, 6 days. In that case, if you measure each and every rebar actually, it will go for more than a month actually. You get it? It's not feasible. Okay. The thing is what happened. If you give 200 millimeters, somewhere it will be like 220, 225, 230. You get my point. Okay. So you're putting yourself in a risk. So what we are trying to do, we are limiting the spacing into 20 cm. We are not even going to give you more than that. You understand? Okay. That is the reason why we start with 100 millimeter spacing. We end up with 20 centimeters, which is 200 millimeters. We'll never go more than that. But code even says actually, it can go up to 300 millimeters. Doesn't matter. But you cannot go more than 300 millimeters. This is I'm talking about center to center spacing. Center of the rebar to center, not the clear spacing. Center of the rebar to center. What is the minimum rebar spacing as per code actually? It's 2 times of aggregate size. What is the aggregate size you are using? 20, right? Isn't it? 20 mm. So 2 into 20 mm, 40 millimeters. You cannot use it. Why? The vibrator needle which you are using at the side, minimum 40 millimeters. You do have less than this, but let us go with this. Because always there is a backup will be there. Okay. If you want to use 40, at least the spacing between the rebar is 60. Then only I can put the vibrator, I can take it out. If you provide 40, then how you can put, first of all, you cannot insert the vibrator. Now the code is not matching. So these are all like practicality, constructability actually, you have to adopt. Code is the guidelines. Code doesn't say it is a mandatory you have to follow each and every. You get my point. Okay, clear, right?
For the required, the minimum should be 30 more. The
Half which was less than this. First over here, so that we will consider 300 or the also check whether it is safe.
yeah, I know 300, so it required minimum in the code. So I think we follow code. But, I don't know how it works in real life. Yeah.
This isn't colors.
No, I think it's not. This is maybe if I can prove we found the unitary state, I think a lot of it. Just
Actually, according to province, it should be.
just go to mathematically and total state populations plus.
Like consider 300 minutes.
Yeah.
Because according to code, it should be minimum is 300.
We found that
Yeah, it's minimum is 300. If you go minimum the less than 300, it is unsafe. Correct?
Yeah.
You consider 300 as minimum. So actually, it's like 333. It's so much hard to execute the actual site.
Yes.
So we can consider, yeah. We can place 350 or 300. Both of them are actually 50 mm. That's it. 50 mm consider. So exact value we can't execute in the actual site. That's the 300 to cross this band, right? That's good. Let's see. But actually, all the semester, the last semester, I've done everything regarding this. I've learned manual this calculation of slab, design of slab, and beam, everything, all of this. So in one class, he teach me all of the semester. So everything I studied in my last semester is this one.
But I'm sure in the class, we will teach more detail.
Yes. Like detail in the sense, I have so much. In end of this one, we got the dimensions, the beam or the slab, but not the space. Like,
Yes, like of the range of the required size.
yes. Check this out. Now see, in this we got the VUS, which is shear, and then we have formula to check base value, and we got the spacing as 144 and so forth. So we use the spacing of 144 between them. So
For that, we can check.
yeah, and there's a limit check, spacing correct check. So we can take 300 as the spacing. Spacing is 300. So this thing is spacing is. Yeah. Spacing is taken first. Spacing. Most of them are similar. They relate. I want to learn about stairs, design of stairs. You know, design of stairs. I want to learn that is not teach to me yet.
For that part, maybe next week or next week.
You can read drawings. You can read the drawings.
And I think drawings.
It's like you understand and read drawings. I don't understand much of this. Like
It's okay. I think
like
I don't know when I use it also. But the problem is that for the drawings, different country, different format. Yeah. So it's different content, different. Sorry, that's not small actually. It's about thing, but not called slab. This is from the photograph. Yes, from the photo we got there are more than 300 feet. Is that possible to just choose from the 250?
We can assume 200 to 250.
Yeah, we just need to prove
Exactly.
work.
This would
Then we can follow that.
We can go for even 250.
No, exactly follow
But this is the basis.
this.
Because I don't want to give you anything that you have idea. We assume something. Because I want to show something which is as per code, what is the minimum thickness is required. Okay. Code is again giving the guidelines to get my code. Yeah. I think I don't want to what we call dump for too many things. Okay. So whatsoever we have seen actually, it's quite comprehensive. Okay. So please go through it actually. Okay. On the next class, we'll focus further. Yeah. Fantastic. Thank you so much. Thanks a lot, Amit. Huh?
Thank you.
I'm ending the session here. And let's focus on the next class actually for further modules.
So
Okay.
next
And
class.
it may not be same like for all the modules. I do understand. Okay. Whatever because sometimes we used to combine two modules.